Welcome back, everyone. This is an Introduction to Functions video part 1. This will be a review for some of you and maybe new to others. Our objectives in this section are to identify function notation, use inputs to calculate outputs, identify appropriate substitutions given a piecewise function, and find domains of specific functions using correct notation. So, if there's one thing you take away from this video, there's a lot of information around notation. The most useful mathematical idea for modeling the real world is the concept of a function. You can think about a function as a rule, and there are infinitely many rules when it comes to looking at functions. The following are a few examples of real-world functions or the need for them. If a biologist finds the function that relates the number of bacteria in a culture to the time, then she can predict the number of bacteria from some future time. If a farmer knows the rule that relates the yield of apples to the number of trees per acre, then he can decide how many trees per acre to plant to maximize yield. The post office has a rule for mailing packages such that the cost is a function of weight. The area of a circle is a function of its radius. And temperature is a function of date. A definition for a function is this: a function f, because usually the default notation is an italicized f, is a rule that takes each x, an element of a set called the domain, also an input, to exactly one element called f of x, element of another set called the range. We read f of x, the letter f, open paren, x, close paren, as f of x, which represents the value of f at x, or the image of x under f. This gets a little tricky when you're reading this out, but it's important to hear how this should sound. It is not what the common error I'll see, f times x. This is a different type of notation. To represent a function algebraically, we use letters such as italicized f, italicized g, and italicized h. And this can be extended into capital letters, etc. For example, if we make f to be the rule, absolute value of a number, then we write f of negative 3. What we mean by this is apply the rule of the function f to the number negative 3, and we read it as f of negative 3. Hence, f of negative 3 equals the absolute value of negative 3. Remember, the rule was an absolute value. And we would get 3 out. That is our output. Similarly, f of 0, when we substitute 0 in as the input, we would get the absolute value of 0, and that is equal to 0. And so in general, f of x equals the absolute value of x, and that's the generic or general form of the rule. If we write y equals f of x, the following are true. Inputs are equivalent to the elements of the domain and are the x values. We can also call these the independent variables. Outputs are elements of the range. We can call these y values, and they are the independent variables. Let's look at the first two examples in exercise 1. We have g of x equals 2x plus 1. We want to evaluate this at a plus 1, so our input is a plus 1. We could also think of this, or call this, the domain. So we will substitute a plus 1 into the function g of x. And now we will have g of a plus 1. And since we are substituting a plus 1 in, we will also replace or substitute a plus 1 wherever there is an x in our function. Next, check to see if you can combine any like terms. Do that by distributing the 2 through. 2a plus 2 plus 1. The 2 and the 1 are like terms, and we will have 2a plus 3. That is the most simplified output. This represents your range. All right, moving on to example 1b. If you have h of x equals 3x cubed plus 2x squared minus 5, and you want to find h of negative b, that means that negative b is your input. You can also call this the domain. Notice how the notation is slightly different, but it means exactly the same thing. We will rewrite h of x as h of negative b, and wherever there was an x in our original function, we will do a substitution with parentheses around the x and substitute a negative b in its place. When I multiply negative b times negative b times negative b, because remember, an exponent of 3 says multiply the base to itself 3 times, we will get 3 times negative b cubed. I'll put that negative out front, b cubed. If I multiply negative b to negative b, I will get a positive b squared, and so I will write this as plus 2b squared. Minus 5, nothing changes on the 5. Since there is no distribution needed here, and there are no like terms left to combine, this is called my range or my output. And I'm done.